Hi everyone, I'd like to talk about conducting a hypothesis testing for a population standard deviation. So here are the 5 major steps. So I hope this is not the first time you see these 5 steps. No matter what kind of population parameter we're testing, we will always have these 5 steps. So now let's look at the problem. Manufacturer uses a new production method to produce steel rods. A random sample of 17 steel rods resulted in lengths with a standard deviation of 4.7 cm. At the 0.1 significance level, testers claim that the new production method has lengths with a standard deviation different from 3.5 cm, which was the standard deviation for the old method. Assume that the population is normally distributed and that the sample has been randomly selected. So let's see what kind of information can we get from here. First of all, a random sample of 17. So that's our sample size, n equals 17. And from this sample, we have a standard deviation of 4.7 cm. So that's our sample standard deviation, s equals 4.7. Our significance level is 0.1, so that's alpha equals 0.1. And we like to test the claim that the new production method has lengths with a standard deviation different from 3.5 cm. So this is actually indicating that under the alternative hypothesis, our sigma is not equal to 3.5, and because it's a strict inequality, that's why we put it under the alternative hypothesis. Moreover, so we're assuming that the population is a normal distribution and our sample is a random sample, and we're testing the population standard deviation, so we'll be using the chi-square distribution for this problem. So that's the same chi-square distribution that you've seen in section 7.4. So first of all, here's our hypothesis. So the claim is sigma is not equal to 3.5, so we put that under H1, which is the alternative hypothesis, and our H0 is sigma equals 3.5. Now for the test statistics, so here's our formula. So n is 17, s is 4.7, and sigma is 3.5. So you will get a chi-square test statistic as 28.852. So now p-value and critical value. So again, in the test, I'll only ask you to do one of them. But you do want to know both of them because you could be asked to do either one of them. Alright, so first let's find the p-value. So because this is a two-tailed test, and the reason it's a two-tailed test is because under the alternative hypothesis, we have not equal. So again, if you're not sure about that, not sure about which test to use, right tail, left tail, or two-tail, go back to the notes on section 8.2. Alright, so because it's a two-tailed test, so we need to double a tail area. And here we'd like to use a new function in our calculator. So go to second, vars, and then scroll down to find chi-square CDF. So this is similar to the TCDF function. So we put a lower bound, upper bound, and then the degrees of freedom. So in this case, the lower bound is 28.852. And the upper bound will be 10 to the power of 10. And then our degrees of freedom is, so our sample size is 17. So degrees of freedom is 17 minus 1, which is 16. So we put 16 here. And then just double that, multiply that by 2. So this will then be your p-value for this problem. Now, a very difficult part for identify given a test statistic is that at the right tail or left tail. Because chi-square distribution starts from 0, it's not symmetrical around 0. So you're always going to get a positive chi-square scores if you calculate it correctly. All right. So what you can see that is you can go to table A4 and then look at the row where the degrees of freedom is 16. So that's the degrees of freedom in this case. And then see, is your test statistic, in this case is 28.852, is that closer to the right side or the left side of the table? So you should see from table A4, the right side have area to the right with small probability like 0.1, 0.05, and so forth. And then the left portion of the table has area to the right like 0.99, 0.9 or something. So just see which is your test statistic closer to the right hand side or left hand side of the table. In this case, it's quite obvious that it's closer to the right portion of the table. So that's why your right tilt area is the probability where chi-square is greater than 28.852. Okay, so that's our p-value. And then for the critical value, so if you forget how to find it, go back to section 7.4. So here alpha is 0.1. So because this is a two-tailed test, so we divide that 0.1 into 2 and distribute each of that to the two tails. So you get 0.05 in each tail. And the degrees of freedom is 16, so we can find these two critical values. So making a decision, so for the p-value method, we're comparing the p-value with alpha. So our p-value is 0.0499, and that's less than 0.1. So it will lead us to reject the null hypothesis. By the traditional method, so our test statistic falls into one of the critical region, in particular the critical region on the right. So because this is a two-tailed test, so we do have two critical regions. So that will still lead us to reject the null hypothesis. Right? So after that, then draw our conclusions, or start with the conclusion template in section 8.2. So there is sufficient evidence to support the claim, and then go back to our question to see what the claim is, which is the new production method has lengths with a standard deviation different from 3.5 centimeter. Okay, so that's it.